Hello guys and welcome to the Sysadmin Tutorials YouTube channel. In today's video we're going to be taking a look at Amazon AWS and how we can create our first Linux EC2 instance. Now if you've never logged into Amazon AWS before, don't worry because I've created a set of articles that will show you how to create a free tier usage account, how to set up multi-factor authentication for that account, and how to set up a billing alarm so that you get an email notification anytime that your costs reach $10 US. So I'm going to be posting the URLs for those articles in the description below of this video. And with that being said, let's get started. So on screen, I've got the landing page for the AWS console, and that's simply https://aws.amazon.com/console. And what I'll do on the right hand side in my account, I'm going to select AWS Management Console. And in here, I'm going to enter in my username, my password, and my multi-factor authentication. Now, once we've logged into the AWS Management Console, we want to go to the EC2 service. So you can simply type EC2 within the field here, or you can click on Services up the top left-hand side and type EC2 here. So we'll click on EC2 Virtual Servers in the cloud. And once in the EC2 service, on the left-hand side, we're going to click on Instances. So as you can see, I don't have any EC2 instances. So like I said in the beginning of this video, what we're going to do is create a Linux EC2 instance, but not only just a Linux machine, we're going to create a web server and we're going to give it a static HTML page that is going to display the internal IP address, the external IP address, and also the DNS name. Now to create your instance, we're simply going to click on Launch Instance. And you'll see in this list that there's many different flavors of instances that you can create, from Linux to Microsoft, etc. So the one that we're going to be using in this demonstration is the Amazon Linux 2 AMI HVM. So just make sure 64-bit x86 is selected and we'll click on the select button. Now for the instance type, we just want to make sure that T2 Micro is selected because this instance type is eligible for the free tier usage. And that simply just comes with 1 vCPU and 1 gig of memory. So now we'll click on Next, Configure Instance Details. Now for the instance details, we're going to be leaving most of these options as default, but what I'd like to do is just step through each one and explain what they do, so that way you have an understanding of what those options are. Now the first option is the number of instances. So we're just going to be creating one instance in this case. For purchasing option, you can request a spot instance. So what is a spot instance? So a spot instance allows you to create an EC2 instance at a fraction of the cost of a standard EC2 instance. And it does this because it uses unused EC2 resources. However, if you use a spot instance, your server has to be able to tolerate disruptions. And let me explain why. If we click on Request Spot Instances, you can see that we have a current price and then we also have a maximum price. As you can see in the current price, it is 0.0035 cents per hour. Now in the maximum price field, you need to put in a price which is greater than the current price. And as long as your maximum price is greater than the current price, your spot instance EC2 will continue to run. As soon as the current price goes above the maximum price, your EC2 instance will be stopped. So for our demo, we're not going to be using spot instances, so I'm going to untick that. Now for network, we've got VPC. So VPC stands for Virtual Private Cloud, or another way you can think of it is a Virtual Private Data Center. So for now, we're just going to be using the default VPC, but in the near future, I will create a new video on how to set up your own VPC. So now we'll move on to subnets. For subnets, I'm just going to drop down the menu so you can see the options. And I'm going to be leaving my option on no preference default subnet in any availability zone. However, you can see that there are some additional default subnets set up. And availability zone, if you're not sure what that is basically a data center within a region. So if we look up the top right hand corner here, you can see I'm in the region North Virginia. So if I go back to subnets, so US East 1E is a data center within the North Virginia region. So I'm going to be selecting no preference default subnet in any availability zone. And we'll move on to auto assign public IP. So for auto assign public IP, I'm going to be leaving it on use subnet setting enable. So what that means is that it's going to be assigning a public IP to my EC2 instance, and we need that for this demonstration to be able to access the EC2 instance remotely via SSH and via HTTP. If I drop down the menu for that option, you can see that I can also disable it. Now moving on to placement group, this basically gives you the ability to group EC2 instances. When you create a new placement group, you have three options. Now one option is cluster. So cluster means a logical grouping of instances within a single AZ. So each instance can communicate with each other at line speed and low latency, and there's no oversubscription. The second option is partition. So it's within the same availability zone. However, each partition has its own set of racks. A partition can contain multiple unique EC2 instances. And the third option is spread. So same availability zone, however, each EC2 instance is placed in distinct racks. So basically that means an EC2 instance per rack. We're not going to be using placement groups in our demonstration, so we'll move on to the next option, which is capacity reservation. Capacity reservation allows you to create a reservation of resources within an availability zone for a specific instance type. This ensures you reserve the CPU and memory of the instance on the underlying hardware. If I click on the drop-down menu for capacity reservation, you can see that there's two options. There's open and none. So open just means that this EC2 instance can participate in a capacity reservation, or none, it does not participate in the capacity reservation. So I'm just going to leave it on default. And now we'll move on to IAM role. Now IAM stands for Identity and Access Management. An IAM role will allow me to assign permissions to access other AWS services. So for example, I could create an IAM role with read and write access to an Amazon S3 bucket, and then I can apply that role to this EC2 instance. When I start this EC2 instance, I'll be able to read and write objects to the Amazon S3 bucket. For this demonstration, I'm going to leave that setting on none, and we'll move on over to shutdown behavior. So I'm going to drop down the menu for shutdown behavior. And you can see we have two options there. We've got stop or terminate. This takes effect when you issue the shutdown command from within the EC2 instance. So if you terminate it, that means that the EC2 instance gets deleted. If you stop it, it just basically shuts down and goes into a powered off state. We'll move on to enable termination protection. And you can see the only option that we've got there is protect against accidental termination. So if I right click on an EC2 instance and I select terminate, it will say that protection is enabled and we will not be able to delete it. I'm going to leave that option as off. So if I do right click on my EC2 instance and select terminate, it is going to delete. We'll move on over to monitoring. So when you create your EC2 instance, it does come with some default basic monitoring, which I'm going to show you later on. You can enable CloudWatch detailed monitoring, which basically just adds a whole heap of other metrics within CloudWatch. And so CloudWatch is the monitoring service for Amazon AWS. We'll move on to tenancy. So I'll just drop down the options here. And you can see we can run our EC2 instance as shared, which runs on shared hardware instance. We've got dedicated. So what dedicated means is that it is dedicated hardware available for your account. So no other customers can run on that dedicated hardware. So that's the second option. And the third option is you can run the EC2 instance on a dedicated host. So it will have the whole host to itself. I'm going to be leaving this EC2 instance on shared. And we'll move on to elastic inference. Now first up, inference means making predictions based on a trained model. So if you enable this option, it allows you to add a low-cost GPU-powered acceleration, which actually helps you to reduce your deep learning running costs or deep learning inference running costs by up to 75%. So I'm definitely not going to be running deep learning on our demonstration, so I'm going to be leaving that as unticked. And the next one is T2, T3 unlimited. So if you enable this option, it allows any instance starting with T2 or T3 to burst its CPU above the baseline for any period of time whenever required. As you can see there is additional charges if it does burst above the baseline. So we're going to be leaving that as unticked. And I'll just scroll down a bit. Now next to file systems, you can see that we can create a new file system. Now what that does, it creates an elastic file system, or EFS for short. And basically that allows us to use NFS. So I'm not going to be using NFS within my EC2 Linux machine here, demonstration. So we'll move on to advanced details and we'll have a look at user data. So for user data, we can enter in commands here and it will execute as if you entered those same commands on the CLI interface. So I've got a bunch of commands that I'm going to enter in here and I'm just going to bring them up on screen. Now these are the commands that I'm going to be entering into the user data box. So we'll just go through them. The first command, we're going to run yum update. So we'll make sure that our EC2 Linux instance is up to date with all security patches. Secondly, we'll install HTTPD service. Third, we'll start the HTTPD service. Fourth, we'll make sure that the HTTPD service is available and started each time we reboot the server. We'll then change directory into var www.html. And then we're going to start writing information into index.html. So the first one is just a heading saying your internal IP address is. In the next command, we're going to be using curl to read the information from this specific URL, which is going to give us our local IP address. This specific URL is used to read the metadata from EC2 instances. So it must be run within the EC2 instance. So you can see that we grab the local IPv4 address and we place it into index.html. We then have another heading, which is your external IP address is. We then use the metadata URL to grab the public IP address and place it into index.html. We then have another title saying your DNS address is. And then we use the metadata URL to grab the public host name and place it into the index.html. So I'm going to grab all this code. And we're going to place it into user data and just make sure that as text is selected here. And we'll click on next, add storage. Now I'm just going to use the default of 8 and just take note that this is not 8 gigabytes, it's actually 8 gigabytes. And if you want to see what gigabytes is to gigabytes, we can go to Google and use the calculation there. So I'll just open up another tab. And all I searched on was gigabytes to GB. So if I put in 8 for gigabytes, you can see that that's actually 8.5 gigabytes. So I'll close that. And now we'll move on to volume type. So I'm going to be leaving mine on general purpose SSD, which will give me 100 to 3000 burstable IOPS per gigabyte. But you also have other options here where you can go provisioned IOPS SSD, and you can type in the amount of IOPS that you require. And thirdly, we can use magnetic standard, but I would only use this for like very slow archive data. So I'm going to move it back to general purpose. And I'll leave delete on termination selected. So if we terminate the EC2 instance, this volume is going to be deleted. If you untick it and then terminate the EC2 instance, the volume will remain and you can reattach it to another EC2 instance later on if you wish. So we'll leave that ticked. And then we also have the option of encrypting the drive. So I'm going to leave mine on not encrypted. And we'll click next, add tags. Now let's click on add tag. And for the key, we'll type in name. And for the value, we'll type in web server 1. I'll leave instances and volumes ticked. So this means that it's going to apply that tag to the instances and volumes for this EC2. And we'll click on next, configure security group. Now I'm going to create a new security group. And the security group name I'm going to type in as web server 1-SG. And for the description, we'll type in web server 1 security group. Now the rules specified here are inbound rules to our EC2 instance. So as you can see by default, it is SSH allowed to our EC2 instance from anywhere on the internet with IPv4. Now if you have the drop-down menu selected as custom, you can change this IP address to any IP address that you like. If you drop it down, you also have the option of selecting anywhere, and you also have the option of selecting my IP. So this is the IP address you're coming from, accessing your Amazon AWS console. It's also the same IP address if you go into a web browser and you type www.whatismyip.com. And if I click on that, it's just going to allow my IP address to that SSH server, which is much more secure than allowing anyone on the internet to SSH into my EC2 instance. And then optionally, you can type a description. Now we're going to add a second rule here. So I'll click on Add Rule. And for type, I'm going to drop down this menu and select HTTP. And as you can see, it's TCP port 80. And for source, I'm going to drop down this menu and select my IP. And I'll give a description. And they're the only two rules that we need for our demonstration. So now I'm going to click on Review and Launch. And here we have a summary of all the settings that we've entered in so far. So we have our AMI details. AMI stands for Amazon Machine Image. We have our instance type, which is our CPU and memory. We have our security groups, which is basically our firewall rules. We have instance details, which were all the options that we went through previously. We have storage. So as you can see, we have our 8 GB disk drive here. And if I expand tags, you can see that we have a tag with the key name and value web server 1. So I'm going to click on Launch. And now we're going to create a new key pair. So what the key pair allows us to do is place the private key within Putty. And Putty will allow us to establish an SSH session to our Linux EC2 instance, and it'll authenticate using the private public keys. So I'm going to show you how we do that with Putty a bit later on, but for now, let's create a new key pair. And now we'll give the key pair a name. So for the name, I'm just going to type in web server 1 key pair. And what we'll do is we'll download the key pair. So click download key pair. And you can see here that the name of the file is webserver1-keypair.pem. So I'll just click on save file. And just make sure that you protect that key pair. This is your access into your EC2 Linux server. And once you've done that, we'll click on launch instances. So here it says that your instances are now launching. So we're going to click on View Instances. And you can see here with the spinning wheel that it's in progress. So it's actually building out our EC2 instance now. And we're just going to keep an eye on instance state. So at the moment it says pending. And then we're also going to check status checks. So one thing I want to show you here, this is not like VMware vSphere or Microsoft Hyper-V where you can just open up a console to the server. But what you can do is you can right click on the EC2 instance. You can go to Instance Settings and then select Get Instance Screenshot. And you can see that our instance is at the login prompt. And you can keep clicking refresh to get updates of the console. So we'll click on Close. So I might just pause the video here because this is going to take a couple of minutes. And once the EC2 instance is fully initialized, I'll resume the video. Okay, we're back and we have our EC2 instance fully initialized now. So what we have is we have a Linux server running a web server and serving out one static index.html page. So that index.html page is going to display the internal IP address, the external IP address or public IP, and also the external DNS. So down the bottom here, we have some information about our server. So we have our public DNS here and we have our public IP address. So if we go to the right-hand side of the public DNS, you can see that two little files pop up, and if we click on that, it's going to copy our public DNS name into our clipboard. So now we're going to go over and open up a new tab, and we'll select paste. And I'll just put HTTP at the beginning, and we'll press enter. And so now we've made a connection through to our EC2 instance, and you can see that the static page is displaying your internal IP address, your external IP address, and also your public DNS. So the EC2 instance and the user data that we've placed into the setup wizard is working 100%. Now I'm going to go back to the management console. And if you have a look at the right-hand side here, you can see that we can adjust the window by clicking on these three icons. So if I click the first one, it makes it quite low. The second one, a little bit higher. And then the third one, even higher still. So in the description, we've got all the information about our EC2 instance. If I click on status checks, you can see that it performs two status checks. So system status checks and instance status checks. So system status checks just make sure that it can get network packets to the EC2 instance. And instance status checks just make sure that your operating system is accepting traffic. So these two status checks here correspond to, if I just make this a little bit smaller, the status check column here. So you can see that 2 out of 2 have passed, and that's based on these two status checks here. So now we'll go on to the monitoring tab, and I'll just make this larger again. So in the monitoring tab, we have a whole heap of basic monitoring metrics. So you can see we've got CPU utilization, disk reads, network packets, etc. And you can see at the top here that we can also have an option to enable detailed monitoring once again. So the detailed monitoring goes into CloudWatch. On the right hand side here, you also have the option of creating an alarm. So one alarm that you might think about creating is if the average CPU utilization goes above 80% for more than 5 minutes, then the alarm gets triggered, which means it can send an email. And you can also specify 4 different actions when the alarm's triggered. So one action is stop the instance. Another one is terminate the instance, reboot the instance, or repair the instance. I won't go through and set up an alarm in this demonstration. Setting up the alarm is quite straightforward. The only thing that I'd ask you to do is, if you want the alarm to send you an email, is check out my tutorial that I did on creating an Amazon AWS billing alarm, and just follow the first section where you set up a simple notification service. And the simple notification service basically creates a topic and an email subscription. So that URL will be in the description below on this video. So let's move on to the tags. And you can see that we've got our tag set up here. And this was the one that we created during the EC2 instance setup wizard. So now that we've verified that the EC2 instance is up and running, we've also verified that our web server is working correctly. Our index.html page is serving the correct information. The last bit of this tutorial that I want to show you is how to establish an SSH session to our Linux EC2 instance using Putty. Now, before we use Putty, we're going to need to convert the key pair that we downloaded previously, and we're going to actually need to save the private key from that key pair. And to do that, we use a Putty tool called PuttyGen. And I'll just go over to the web interface now. And if we scroll down, we can download PuttyGen just here. Once it's downloaded, we'll double click and open it up. And what we need to do, we need to click on load, and then we need to browse to where that PEM key pair file that we downloaded previously. And we need to select that, and it will import the information into the Putty key generator. So here's my web server 1-keypair.pem file. So I'm going to select that. And you can see that the key pair has been imported successfully, so we'll click OK. Now we'll enter in a key passphrase for this key. And then we'll just confirm it on the second line. Once you've done that, we can then click on Save Private Key. And I'm going to give it the file name webserver1-priv. And we'll click on save. Okay, we can close the key generator now. And we'll open up Putty. And within Putty, we need to put in the host IP or DNS name. So we'll go back to our EC2 management console. And we'll just click back on description tab. And I'll just copy the DNS name to my clipboard again. And then we'll go back to Putty. We'll paste in the host name here. We'll make sure that SSH is selected. And we might save this session as web server 1. So I'll click on save. And now we need to import our private key. So we'll go down to SSH just here. We'll expand that. And we'll click on auth. And where it says private key file for authentication, we'll click on browse. And we'll select the web server 1-priv.ppk file that we created with PuttyGen. Click open. And we'll actually just go back to session, make sure web server 1 selected, and then click save. Okay, so that'll save the authentication private key file. And then we'll click on open. We'll click on yes, that we trust the host. And the username that we need to type in here is EC2-user. And we'll press enter. And I'll just expand this box a little bit. And here we put in the passphrase that we entered in for our private key. And enter. And that's it. We've established a CLI session to our Linux server. Okay, that concludes this tutorial on setting up your first Amazon AWS Linux EC2 instance. I hope that you found it informative, and if you have any questions whatsoever, please leave them in the comments below. If you like the video, I'd appreciate a thumbs up, and we'll see you again in the next video. Thanks for watching. Bye for now.